Hello, grade 10. This is your term 3 physics. It's going to be with me, Miss Nasser, and it is going to be about oscillations and waves for half of the term, and then the end of the term we'll be talking about radioactivity. Now, this week's task is not big. It's just definitions and getting you into the topic. So again, the topic is called waves and it includes all types of waves. We're going to talk about characteristics of waves. We'll be talking about light and sound and their behavior. So the objectives for this week is only to demonstrate understanding what a wave is, how it transfers energy without the transfer of matter. And then you will also see how vibrations can happen in ropes, and then we'll distinguish between transverse and longitudinal waves. So 2 types of waves we'll be talking about in this week. To start with, guys, there are 2 types of waves that we will talk about. But before we do, we need to know what is a wave. A wave, this is the best definition. It was very hard to define, but the best way to say it's just a means by which energy can be transferred. We're not just transferring energy, we are also transferring information, because all this telecommunication that's going on, all the signals coming to your phones, all the signals we're getting through the internet, they're all waves. So they are transferring information, but you have to say this, without the transfer of matter. Meaning, matter here are the particles. Particles are the matter. They don't transfer. I'll show you what I mean. Here is a simulation that I find really helpful. Now, if I play it, this thing is called oscillator on the left side. I'm going to let that oscillator oscillate. Here's a rope and it's red and there are green particles there. The red and green particles is the matter we're talking about. Now, look, here is the vibration or the oscillation. Is that metal thing on the left bouncing up and down. Yeah? So the bouncing up and down is called oscillation. Some books, they call it vibration. Now, I want you guys to look at the particles. What I'll do, just let's look at the green one, the second green one from left. If you look at the left side, the second green particle, I'm going to make that particle move in slow-mo. Watch this particle. It looks like it's moving up and down. So it did not leave its position. But to me, the wave looks like it's going towards the window. So here, the vibration of the particle is up and down, but the wave is transferring towards the window. So look, the particles or the matter is not being transferred. The green particle didn't leave its place. Yes, it's jumping up and down, but it's still in its own position. It's like Mexican wave. When you're in a football match in between audience and then all the audience decide to do this Mexican wave, they all stand up in order. So you stand up and you sit down in your place. You don't move with the wave. And the wave looks like it's going between the audience. And that is the definition of wave.